Hello everyone, this is Sreeja Atluri from University of Windsor pursuing Masters of Applied Computing. Now I'm going to present our final project on Advanced Computing Concepts. The instructor of the subject is Dr. Abed Al-Khatib and my group members are Manat Jyot Singh, Priyanka Mogha and Pranaya Challa. During this presentation, we are going through the role of each team member in doing this project. We are going to deal with what a web search engine is, along with what are the various features that we have implemented in our system. Later, we are going to discuss further the web search engine main functionality, that is web crawler, and then about other features including HTML to text parser, searching, ranking, and autocorrect. After that, we are going to talk about a flow diagram about the system that we have made, and then we can see the demo of the running code which gives the actual results, and then all followed by the future scope. During this project, each member of our team had made their own contribution. Manat Singh has implemented the web crawler. Priyanka Mogha has implemented the searching part using Boyer-Moore algorithm. Sreeja Atluri, myself, implemented the autocorrect functionality using edit distance. Pranaya Challa has implemented the ranking functionality using sorting. Along with this, we helped each other in doing this presentation. So now let's get started with the introduction. What exactly is a web search engine? A web search engine is nothing but a software application based on the user search query, which might be keywords or phrases. Based on the user search query, it then provides the best suitable URL or web pages user is looking for by crawling the web to find the relevant information and index it. When a user inputs a keyword, the web search engine finds relevant results for that particular query, implying various algorithms such as web crawling, sorting, edit distance, inverted indexing, and storage functionalities. Web browsers can be used to perform searching on World Wide Web. Examples of such web search engines that we almost use daily are Google, Bing, DuckDuckGo, etc. Now, to introduce the features implemented in our system, I quickly pass it over to Pranaya, who will take charge of the presentation from here. Thank you very much.
Thank you, Shrija. Coming to the features, we have crawling. Crawling the web URLs using JSON and getting the HTML pages. HTML to text. Downloading the HTML pages and converting them to the text formats. Indexing and ranking. Indexing the words from text files, sorting the files on basis of occurrence of the words in each file. Searching. Searching the input words and presenting the output. Autocorrect or word suggestion using edit distance. We have a web crawler which will go through all the URLs of the website, and then HTML to the text formation is being performed. The keywords are extracted and the pages are ranked. Edit distance is used to determine the similarity between two words. The Boyer-Moore algorithm is used here for pattern searching feature implementation. Web crawler. Do you ever wonder what search engines go around? It's fascinating, isn't it? The way some mechanisms can systematically browse the World Wide Web for web indexing or web spidering. A web crawler is precisely what we are talking about. It's an internet bot, also known as web spider, web robo, or simply a crawler. A web crawler is a program in our app that browses the World Wide Web to index pages for a search engine. Search engine performs crawling by visiting the sites through the links between the web pages. Crawlers are looking for links on the pages and storing the metadata to understand the features. Our crawler program prepares the web search engine for the next stage of indexing. It's amazing how search engines work, update their web content, or do their maintenance tasks. But what's more amazing is the way web crawlers make it happen. HTML to text parser. Parser is used to save the web pages into HTML and text files after the crawling is performed. HTML files are downloaded from the specific URL using the web crawler and stored in the specific local directory. It reads the HTML files and converts it into the text data. Gets the text out of HTML file by calling the text function of the JSON, removes the HTML tags to get the plain text. JSON parses the HTML data to text data. It has some APIs which can help in extracting and manipulating the data from the HTML file. Using JSON, created an object of document type to get the HTML file. Got the actual text from the HTML page using the text method of JSON library. Using regular expressions and split functions, the word with special characters has been split. The count of the word increases according to the occurrence of the word. The search operation is performed on the converted text files. Next will be continued by Priyanka. Thank you.
Thank you, Pranaya. This is the another feature of our web search engine, that is searching. It is similar to Google search. We enter a keyword and we get a list of relevant data based on that keyword. Searching is implemented using Boyes-Mod algorithm, as it is the most efficient string searching algorithm, and as compared to other string searching algorithm, it is the fastest one. This algorithm matches character by character from rightmost to the leftmost. For instance, if keyword is apple, the algorithm match start from the rightmost character, that is E, and goes to the character A, that is the leftmost. If a character matches, then it will move to the next character. If match is not found, then search jump to the next matching character position. Next feature we have, that is ranking. This feature ranks the page based on the frequency of words. After performing search operation, it finds the occurrence of keyword in all the relevant data, which is generated through search operation. Top 5 pages with the maximum occurrence of keyword will be selected and then displayed to the user. It sort the HTML pages with the most relevant to the least relevant data, and result are stored in hash map data structure. For sorting pages, merge sort algorithm is used as it can handle large chunk of data. The last feature is the autocorrect feature. It provides relevant suggestions if any user query is not found. It recommends nearest possible keywords. We have used edit distance algorithm to implement this feature, as this algorithm finds out the minimum number of edits required to convert string 1 to the string 2. For instance, if a keyword which is entered is CET, that is cat is misspelled as CET, then this algorithm will give a suggestion of CAT as a string 2, as both string 1, that is CET, and the string 2, CAT, will have minimum number of edits, and that's the best possible suggestion for that incorrect keyword. This algorithm will find all the words that are having proximity to keywords from the user search query. And here is the flow diagram of the web search engine. We have three options: first crawl, search, and exit. If we select crawl, we need to enter the website URL which we want to crawl. Web crawler will crawl that entered URL website, and parsing is performed using JSoup, which will convert HTML file to text files. We can perform crawling on other websites by just entering the website URL, and web crawler will crawl that website, and parsing is performed that will convert HTML files to the text files. If we select search option, then we need to enter a keyword which we want to search on web. Search feature will search for that keyword. If no result is found, then autocorrect feature will suggest similar words to the keyword, and again searching is performed on that modified keyword based on the similar word suggested by autocorrect. And still no word, still no result is found, then autocorrect will again suggest similar words and again searching is performed. If we get result for the entered keyword, then occurrences of keyword are found in the data, and the data is ranked by ranking functionality based on the occurrence of keyword, and top 5 results are displayed to the user. And we can use exit option to exit the web search engine. Now I hand over to Manat to further discuss about future scope of the project.
Next, we will begin with the small demo of the application. So to run the application, we run this file search.java, and you can see three options when you get here. So the three options are crawl, search, and exit. So if you type exit, it will simply exit the application. If you type search, it will ask you the keyword which you want to search for. And if you type crawl, it will ask you for the link you want to crawl. So to implement crawling, which is the first feature, we are using JSON, and the code is written in the file webcrawler.java. So once you enter the link, it will parse 10 levels in depth, and we are using JSON to first crawl and then convert the HTML files into text, which are then stored in the output folder, which is the crawled pages. Next feature is searching. So let us say you want to search for a keyword. Once you enter a keyword, the application searches for the keyword in the crawled pages. And for searching, we are using the Burm or pattern matching algorithm. Let's say a keyword is found. So we come to the third feature, which is sorting or ranking. So to rank the web pages, we are showing the top 5 results to the user. Those results are shown on the basis of the frequency of the keyword in those files. So let us say if a keyword was found in 100 files, so we will show the top 5 search results to the user based on the frequency of the word. And let us say if a word is not found, then we come to the final feature of the application, which is autocorrect. Autocorrect has been implemented using the edit distance algorithm. So the application maintains a list of all the keywords which are stored in this file, dictionary.txt. And once you search a keyword which is not found in any of the pages, it will go to this file. It will find the two words which have the minimum edit distance, and it will output that to you. So let us say if there are more than two words which have the same edit distance. So in that case, we pick the ones which come first alphabetically. So let's do a small demonstration. Say we run the file search.java. So you have three options. So let us say I want to crawl. So it will ask me about a website which I want to crawl. So let's say I crawl cbc.ca. So it'll tell you which link it is parsing at the time. Since crawling takes a bit of time, we'll stop it right here. And the output of this is stored in this folder. So let's run the application again. Yeah. Yeah. So let us say I want to search for a keyword. So let's say I enter my search query, Canada. So as you can see, it is searching for the word Canada in all of the files, and it will tell you that it found the search, or the search was found in 148 files, and these are the top 5 search results, and we can see the file names and the number of times this keyword occurs in those files. So this has been implemented using the Bergmore's algorithm, and ranking has been implemented using sorting. So let's search for another keyword. Say I search for sport. So it tells me that they found it in 123 files, and these are the top 5 search results based on the frequency. Now let's test the autocorrect feature. Let's say I misspell Canada. So it did not find this word anywhere. So it is giving me suggestions that do you mean Canada or Antaya. So again, these are the two words which have the minimum edit distance, and these words are basically the keywords which were found in the pages crawled. So let's try another word for autocorrect. Yeah. So let's say I search for sport and I misspell it. So as you can see, this word was not found, so it gives me suggestions like do you want to search for port or sport. So these are the two words with the minimum edit distance. Now next we'll talk about the future scope of the application. As you just saw that this is a console based application, so the next logical step would be to add a user interface to this. Another thing which we would do is connect this application to a database, and we can use that same database to store user preferences and user search history so that their results are refined as per their past history. Another thing which we could include in this are the regular expressions. Yeah. So if you guys have any questions, please feel free to reach us on any of the given emails. And these are some of the references which we took for our project. So these are both code and documentation references. And yeah, thank you so much for your time. Thank you for watching.